Welcome to SO 305, Lecture 11, Measure of Dispersions and Variability 2. Introduction. In the discussion of the mean deviation, we considered the differences of x1 minus x. We had to take their absolute values, otherwise the sum would have been 0. Another way of converting the differences x1 to x into positive quantities is to square them and add the squared differences. This sum, when divided by n, that is the number of observations, is called the variance of the observations. In view of the above, this lecture focuses on the calculation of the variance and the standard deviation for both grouped and ungrouped data. Objectives. At the end of this lecture, you should be able to calculate the variance for both grouped and ungrouped data and the standard deviation for both grouped and ungrouped data. Pre-test. What is the variance for 3, 4, 5, 6, 5, 7? A. 1.67, B. 2, C. 2.5, D. 1.41. 2. What is the standard deviation if the variance is 22.7? A. 10.23, B. 4.76, C. 11.35, D. 5.25. Content. The variance and the standard deviation. By definition, variance is the average of the sum of squared deviations from the arithmetic mean. The essence of squaring the deviation, as earlier mentioned, is to eliminate the problem that may be posed by the negative signs that will eventually give zero summation. Here the formula for calculating variance is A. Using deviation method, n s2 equals e bracket x minus x bar bracket square all over n. N s square is equal to ef bracket x minus x bar close bracket square all over n. B. Using Ross-Cobb method, s square is equal to es square minus ex bracket square all over n. All over n. S square is equal to es square minus bracket ex square all over n minus 1. For the purpose of estimation, it is better and in common use to calculate variance by introducing Bessel's correction factor by dividing the squared mean deviation by n minus 1 rather than n. In this lecture, we shall calculate the variance both for grouped and ungrouped data using n s squared is equal to e bracket x minus x bar close bracket square all over n minus 1. For ungrouped data, n s squared is equal to ef bracket x minus x bar close bracket square all over n minus 1 for grouped data. The standard deviation is the positive root of the variance. Therefore, the same logic applies to this measure of variability. The formula for standard deviation is s square root n e x minus x bar close bracket square all over n minus 1 on group data. S is equal to square root n ef x 1 minus x bar bracket squared all over n minus 1 group data. The following steps are to be taken when finding either or both the variance and the standard deviation. 1. Find the arithmetic mean of the distribution x. 2. Find the deviation from the mean, each value of x in Ross course, and midpoint value x for group data, x minus x bar. 3. Square each deviation x minus x bar square. 4. Multiply each step 3 by the class frequency to obtain f into bracket x minus x bar close bracket square. Applicable only to group data. 5. Sum these products by either step 3 for ungrouped or step 4 for group data. 6. Divide the sum of these squared deviations, for example step 5, by number of cases in the distribution less 1 in brackets n minus 1 to get the variance. 7. Find the square root of the variance, for example step 6, to obtain the standard deviation. Properties of standard deviation. The following are the main characteristics of standard deviation. 1. It gives a measure of dispersion relative to the mean. This differs from the range, which gives an absolute measure of spread between the two most extreme scores. 2. It is sensitive to each score in the distribution. If a score is moved closer to the mean, then the standard deviation will become smaller. Conversely, if a score shifts away from the mean, the standard deviation will increase. 3. It is stable with regard to sampling fluctuations. This makes it useful for reporting variability. 4. It can be manipulated algebraically, hence the use in inferential statistics. 1. For ungrouped data without frequency. Find the variance and the standard deviation for the following scores in statistics: 5, 7, 8, 12, 18. Solution. Step 1. Find the mean, equals to 5 plus 7 plus 8 plus 12 plus 18 divided by 5 equals to 50 divided by 5 equals 10. Step 2. Find the deviation, column 2. Step 3. Square each deviation, column 3. Step 4. Sum the product of column 3 equals to 106. Step 5. Divide step 4 by n minus 1 equals 106 equals 106 divided by 5 minus 1 equals to 26.5 over 4. Variance. Step 6. Find the square root of step 5 equals 26.5 equals 5.148. Standard deviation. Square root ex minus x bar close bracket square all over n minus 1 is equal to square root 26.5 equals to 5.148. Another way of working the variance and the standard deviation is s squared is equal to square root x squared minus n x bar squared all over n minus 1 for ungrouped data. N squared is equal to square root x squared minus nx squared all over n minus 1 for grouped data. Using table 19 and the new formula, calculate the variance and the standard deviation. Formula: s squared is equal to square root x squared minus nx bar squared all over n minus 1. Step 1. Calculate the arithmetic mean, equals to 5 plus 7 plus 8 plus 12 plus 18 divided by 5 equals to 50 over 5 equals 10. Step 2. Find the value of x squared, column 2. Step 3. Sum up the value in x2 is equal to 606. Step 4. Find n minus 1 equals 5 minus 1 equals 4 and n equals 5. Substituting: s squared is equal to 606 minus 5 into bracket 10 squared all over 5 minus 1 is equal to 606 minus 5 in bracket 100 close bracket all over 4. 62 is equal to 606 minus 500 over 4 is equal to 106 over 4 is equal to 26.5 variance. 2. Variance and standard deviation for data with frequency but not grouped. Find the standard deviation and the variance for the following age distribution of students in a class. Step 1. Calculate arithmetic mean equals to EFX all over EF is equal to 147 over 20 equals to 7.35. Step 2. Calculate the deviation column 4. Step 3. Square column 4 to give column 5. Step 4. Multiply each manipulation in column 5 by column 2 to give column 6. Step 5. Sum up column 6 for EF bracket x minus x bar close bracket square is equal to 30.55. Substituting in equation, S is equal to square root n EF bracket x minus x bar close bracket square all over n minus 1 is equal to square root 30.55 over 20 minus 1 is equal to 30.55 all over 19 is equal to 1.608. Variance is equal to 1.268 standard deviation. Using an alternative method, calculating the standard deviation and the variance of table 21. Solution. Using the formula S is equal to square root EFX squared minus n bracket x close bracket squared all over n minus 1. Step 1. Calculate the mean equals to EFX over EF is equal to 147 over 20 is equal to 7.35. Step 2. Calculate x squared column 3. Step 3. Calculate fx squared column 4 and sum up is equal to 1111. Substituting in the formula, S is equal to square root EFX squared minus n bracket x squared all over n minus 1 is equal to square root 1111 minus 20 bracket 7.35 close bracket squared all over 20 minus 1 is equal to square root 1111 minus 20 bracket 54.0225 close bracket over 19 is equal to square root 1111 minus 1080.45 over 19 is equal to square root 30.55 over 19 is equal to square root 1.608. Variance is equal to 1.268 standard deviation. 3. Coefficient of variation. It sometimes happens such that we need to compare the variability of two or more sets of figures which are expected in different units. The coefficient of variation then reduces the various measures into ordinary numbers so that comparisons can therefore be made. This reduces the various measures into ordinary numbers so that comparisons can then be made. The popular ones are 1. Coefficient of quartile deviation equals to quartile deviation divided by mean. 2. Coefficient of mean deviation is equal to standard deviation divided by mean. 4. Coefficient of variation CV is equal to standard deviation times 100% divided by mean. For example, CV for table 19 is CV equals to SD divided by mean times 100 over 1 is equal to 5.148 divided by 10 times 100% divided by 1 is equal to 51.48%. Summary. In this lecture, we have examined the calculation of the variance and the standard deviation of both the grouped and ungrouped data. Variance is the average of the sum of squared deviations from the arithmetic mean. The standard deviation is the square root of the mean of the squared deviation. We have come to the end of SOL 305 and study session 11. Thanks for listening.